Yes, student, the next content is haloarenes. Okay, in the previous classes we have checked about haloalkanes, but now today we are going to deal haloarenes and its nucleophilic substitution reactions. Actually, its method of preparation is already dealt by us. Now we are going to discuss its chemical properties. Student, in haloalkane we have seen there is a CX bond. Like if I write haloalkane, because we have to do comparative study. Say this is RCX, this is haloalkane, isn't it? But what about haloarene? Haloarene, there is also CX bond, okay, but the C belongs to what? Benzene ring. It belongs to benzene ring, and there is what? X, isn't it? Means what is the difference? Here the carbon is sp3 hybridized, but here the carbon is sp2 hybridized. These are some basic differences between haloalkane and haloarene. Nucleophilic substitution reactions occurs when the halogen atom, okay, in the form of halide ion is substituted, okay, by any other nucleophile. Similarly, if we have to watch the nucleophilic substitution reaction of haloarene, then again the same thing, that is the CX bond is to be broken and the X should release in the form of X anion, okay, by other nucleophile. Such reactions are called nucleophilic substitution reaction, isn't it? Like here, if we talk about any nucleophile, then it will form RCH, and nucleophile, that is this one is nucleophile, isn't it? And the X is substituted. Similarly here, what? If we react it with any other nucleophile, then the compound will be, okay, this is what? C carbon, and there will be new chemical bond between nucleophile and the X is getting releases. Such reactions called nucleophilic substitution reaction. I told you we have to compare, okay, the ease of reaction, that is the same reaction, whether it will take place easily in haloalkane as well as haloarene. So here is the point of discussion. So there is a question: are nucleophilic substitution reaction okay, also takes place, okay, easily as, okay, easily in haloarene as, okay, in haloalkane. So this will be our point of discussion. That is, in the two cases nucleophilic substitution reaction takes place, but whether the ease of reaction are same for both the reactant, this will be our point of discussion. You can write the answer, what? Haloarenes do not easily gives, I am writing in short, nucleophilic substitution reaction. Isn't it? Haloalkane easily gives, but haloarenes do not easily give nucleophilic substitution reaction. Now the question is why? Okay, so to discuss its answer, again we have to check the nature of the two reactants, because the chemical properties depends completely on the nature of the reactants. Okay, so the reason, okay, number one, in first one, what? Resonance. Okay, in haloarenes, you can take a simple example of haloarene, what? Chlorobenzene. Now student, look at, there is what? Benzene. So in haloarene, that is what? Chlorobenzene, resonance occurs. Now why resonance occurs? Because the compounds of benzene shows instability. So to be stable, okay, the resonance occur, and through the resonance the haloarenes stabilize itself. Resonance occur, to which it stabilize. Okay, that is, it becomes what? Stable. Sorry, stabilized. Isn't it? Therefore, okay, there is partial double bond character. Partial double bond, okay, character, okay, between carbon and halogen. Then how will we express it? We will express by dotted line. Okay, carbon and halogen, getting, which decreases bond length. Hence the bond dissociation enthalpy. Enthalpy increases. Okay, student, actually what? Due to resonance, there is some double bond character, that is partial double bond character. Now student, if there is partial double bond character, then what? The bond length between C and X will decrease. You know that the bond dissociation enthalpy is inversely proportional to bond length. Okay, for substitution, it is important to break down this CX bond, but being its bond dissociation enthalpy increases, therefore the breaking down of CX bond becomes difficult. And if it will become difficult, then this compound will easily do not give nucleophilic substitution reaction, isn't it? Hence the bond dissociation enthalpy increases, so breaking of what? CX bond. Now I am showing what? Partial double bond character. Breaking of CX bond becomes difficult. So this become one of the reason, okay, that why it easily do not give nucleophilic substitution reaction. So this is the reason number one. Actually, some more reasons are also there, which we have to discuss. Yes, student, reason number two. Okay, electronegativity of sp2 hybridized carbon of what? Benzene. Okay, student, actually you should know the electronegativity concept. It is the tendency to attract shared pair of electron. This is known as electronegativity. Okay. In the case of chlorobenzene, okay, carbon is sp2 hybridized. Okay, so its electronegativity is more. Okay, so shared pair of electron of which bond? Of what? CX bond. Okay, is shifted more towards carbon. Okay, hence the polarity of CX bond is lesser. Now student, you know the polarity is proportional to reactivity. If it is less polar, then it will be less reactive. Hence it is what? Less reactive. So this is what? Your second reason. Are you getting? Now this become what? Two very important reason. If the question is asked against, okay, 1 mark, then you give one reason. If it is asked against 1.5 marks, then you have to give 2 reasons. Okay, to explain it, you can draw their structure properly. Like this is what? Carbon of benzene ring, and this is what? Anything, halogen, chlorobenzene, bromobenzene, any of the thing. So there is what beta? There is partial double bond character. One more thing, what? This is what? sp2 hybridized. sp2 hybridized means what? S is having 33.3% character and the P is having 66.7% character. But if we observe the electronegativity of carbon of haloalkane, this is haloalkane. Student, here carbon is what? sp3 hybridized. That means what? The S character is 25% and the P character is 75%. Student, as greater the S character, more will be its electronegativity. So being in haloalkane, the carbon have 33.3% S character, which is higher than S character in haloalkane. Therefore, the tendency of attracting shared pair of electron is more, and if it will attract more magnitude of electron towards itself, then what? The polarity will decrease. Although this is polar and this is also polar, but it is lesser polar as compared to the carbon X halogen bond of haloalkane. Therefore, the bond to break the bond require what? More energy. Now student, these become the two reasons. Can you search some more reason? This will become your homework, isn't it? Now we can proceed with the same content. Okay. As what? Haloarenes easily do not gives which reaction? Nucleophilic substitution reactions. Okay, so if special conditions are applied, special conditions, okay, of what? Of temperature and pressure are applied, then the reaction becomes easier. Then the reactions becomes easier. Okay, so what should be that condition? So here we can say first one, nucleophilic substitution reaction of haloarenes. Okay, and the condition is what? When you can take any simple example of haloarene. What? When chlorobenzene, okay, is strongly heated. Look at this is the condition. What? Chlorobenzene is strongly heated. Okay, at 650 Kelvin. Okay, temperature, and in 200 atmospheric pressure with, now one more thing, what? Strong alkali. With what? Strong alkali. Alkali, that is hydroxide. With strong alkali. Okay, then it forms what? Phenol. It forms phenol. That is what? That is, now you take the example of chlorobenzene. This is what? Chlorobenzene, okay, and reacted with strong alkali like sodium hydroxide, potassium hydroxide. They are called strong reagent. And the condition is what? Condition is 623 Kelvin temperature and what? 200 to 300 atmospheric pressure. Now the Cl can be substituted by what? OH of alkali. This is what? OH of alkali forming what? Phenol. Okay, so student, if the special conditions are applied, then the nucleophilic substitution reaction takes place, and these special conditions are what? The conditions of high temperature and the conditions of high pressure along with the reagent which we have selected. This is what? Strong alkali, okay, sodium hydroxide or potassium hydroxide.